Okay, we're broadcasting, and what we're doing is the intersection of three planes. Now, planes can intersect in a bunch of different ways. They can intersect in a single point. Three of them can intersect in the same line. You can have like a top 10 arrangement, planes intersect in three different lines, basically in pairs. You can also have parallel planes that don't intersect, and two parallel planes that intersect with the third plane and in two lines. So today, actually, we're going to look at finding where three planes intersect, and in this case, it's going to be at a single plane. And then we're going to look at what it looks like when we have two parallel planes that intersect with them. Okay. Equations of three planes. We have three equations and three unknowns. So this is just like the scalar version that we looked at before, except that we've just moved the d, the constant, over onto the other side. And now we're ready to solve this system. It is elimination, just like the elimination that you did in grade 10, but with a couple more steps because we've got more variables. There's a thing called a matrix representation that you're required to know. So we do the same thing with the matrix, okay? And it's pretty straightforward. I'm going to write this system of equations in Gaussian matrix. Hopefully, it's pretty obvious where it comes. So I change equation 1, into the first row of this Gaussian matrix, and it's 1, -2, -4. And I put a line here where the equal sign would normally go. I put a 9 there. Okay, so all I've really done is kind of thrown out the variables. I have something that's slightly easier to look at and deal with. And calculus, nothing really cool happens with it, but they are pretty cool in other contexts. Okay, that is that. So this is the equation representation. This is the matrix representation. I'm going to do solving the equations first, then we're going to look at what it looks like when I'm dealing with the matrix. Three equations, three unknowns. I have to start by eliminating variables. I eliminate them in pairs as I work with these equations. I'm going to do this over here just to kind of save space. I want to eliminate x. Now, I could eliminate y and z when I'm dealing with the equations. Normally, when we're dealing with matrices, we're trying to eliminate the numbers in these positions here. So that's why I'm going to choose to eliminate x. So basically what I'm going to do is I'm going to take equation 2, and so 3x plus 4y plus 3z equals -8. And I'm going to subtract, I want to get rid of my x, kind of arbitrarily, but we'll see why, 3 times equation 1. Okay? So 3 times equation 1 is 3x minus 6y minus 12z equals 9. All right. So I've just multiplied equation 1 by 3. Now I'm going to subtract everything. I've gotten rid of my x here, and I'm going to subtract -6 from 4. So it's very easy to get into trouble because it's easy to forget. Subtracting negatives or adding. Plus 15z equals -8. Subtract 9 is -17. That is a homely result. I'm going to call this equation 4. Okay, so now I have this equation, and it is one equation with 2 unknowns. I want to make a second equation that has 2 unknowns. And so what I'm going to do is I'm going to take equation 3, which is just 2x plus y plus 6z equals 7. And I am going to subtract 2 times equation 1. Okay? And so equation 1 times 2 is 2x minus 4y minus 8z equals 18. Now I'm ready to subtract, and my x is going to disappear. Y subtract -4y is 5y. 6z subtract 8z is 14z. I've done everything right. I have not. Oh yeah. So far, so good. And then 7 subtract 18 is -5. Okay. Just double check. Oops. All right. Okay. So this is equation 5. Okay, so I've got 2 equations and 2 unknowns. I am all ready to go ahead and get rid of another variable. So to do this, I'm actually going to do equation 4 subtract 2 times equation 5. So I'm going to get rid of my y variable. Okay. So let's do it over here. 10y plus 15z is -17. And now I'm going to do 2 times equation 5, which gets me 10y plus 28z, and is equal to -22. All right, I'm going to subtract these. So I got -13z is equal to and -17 plus 22 is, okay, I've got a mistake here somewhere.
Yeah, you're subtracting 4 and 5.
So I'm subtracting
5 and 4.
I'm subtracting this, which is 2 times 5.
Yep.
Okay. And I'm going to subtract it from 4. Yeah.
Gotcha.
Okay. Okay. Morgan, I've made a mistake somewhere. Do you know where it happens to be? Somewhere there's a problem in here, because Z should be 1.
No, I'm looking though.
Okay. 17, no, -17, subtract -22, so this is -17 plus 22. That comes down to a 5. So we've got a problem somewhere in here. This is equation 2. -8. This is 3 times equation 1. 3 minus 6. Minus, oh,
Minus 2.
3 times equation 1. So it's right here. This should have been a 27 right there. Okay. Here we go. 8 minus 27. Sorry, -8 minus 27. -36. I think this is going to make it work. Okay, so this is equation 4, and then -36. And -36 plus 22, that's also got a problem. Times 1.
N equals 14.
Oh, so this is 22. Yeah, so this is 14. Oh, we're awfully close.
We're getting there.
We're getting there. Got to skunk this out. Two times equation 1. 2 minus 4y minus 8z. That looks right. Subtract. Oh, what's this? There it is. This is -35.
Oh my god.
Yeah. How do you like that?
I can't do this in pen.
Okay, there we go. -13z is equal to 13. All right. Z is equal to -1. That's easy. As you can see, it's easy to make lots of mistakes. All right. What am I going to do now? Morgan, any ideas? No, that's -1.
Subbing Z into the original.
Yes, so I'm not going to go into one of these originals. I'm actually going to go into either 4 or 5. And I'm going to get a value for Y. Okay. Which one's easier? 4. Number 4? Yeah, okay. They both look equally dumb. So negative 1, 2, 5. So 10Y equals negative 35 plus 15. Okay. 10Y is equal to negative 20. So Y is equal to negative 2. There we go. So I've got Z is negative 1, I've got Y is negative 2. Now I can substitute back into any equation. Okay.
Any of the original equations?
Yes, so now I'm going to have to go back into one of the originals just because it involves an X. So I'm going to put use number 1. So X is, no, sorry, Z is negative 1. So
Can we finish off like the negative 35 plus 15? Or do I have to leave the negative 35 plus 15, or can I just make that one number?
Negative 35 plus 15?
Yeah, can I actually do that, or do I have to? Oh, you did it.
Well, you might be looking at a small screen, so. Or you could be blind. We never know. Okay, minus 4. And what is my Z here? Times negative 1 is equal to 9. So X plus 4 plus 4. So,
What are you subbing into right now? 1?
So, yeah, sub into 1.
It should be X minus 4 plus 4 equals 9, right?
What is X? Oh, Y is negative 2.
So X minus 4.
Subtract, and this is a negative, so we have plus 4. Yeah. X plus 4 is equal to 9. X is equal to 1. Okay. There we go. That was that. 3 equations, 3 unknowns. I have to do elimination, eliminate between 2 pairs of lines. Do it again to get 2 equations and 2 unknowns. Then I do elimination again. And I'm going to get my variables that way. Okay, when I substitute back, I have to successively substitute back. All right. Good so far? Does it make sense?
And just, this is 3 planes that I'm over done.
So this is 3 planes, and they intersect in a point. Okay, so this point is the only point that lies on all 3 planes. So we call that a solution. Lies on all 3 planes. Okay. Here we go. Now we're going to do it as a matrix. Okay, and we're going to look at what that looks like. We aren't going to do what they call the full Gaussian reduction. We're just going to work with this matrix right here. Okay. So not doing anything with.
Is this like a second way that you can do it, or like?
So I'm just showing you, this is going to be exactly the same set of things, but it's done using a matrix instead. And the operations are the same. We're going to use the exact same operations. So it's not really a different method, but a different representation.
Sorry, computer person, I'm just gonna interrupt for 1 second.
Vice Principal Brewer is interrupting.
Sorry, I'm rude that way. Sarah Hill says it should be half an hour late. She already been here and gone.
She's been here and we're in the middle of
Okay, so-
labeling, yeah.
Give you the message a little late.
Okay, it's all good. I already got it. Yep.
So is this like an easier way to figure it out?
It is slightly easier. Okay, when you're dealing with matrices, this is sort of an error-prone thing. Okay, it just is because of all the subtracting and all that sort of stuff. This is going to be no different than when we dealt with the equations. Okay, maybe a little tight here. That's all there is to it. Okay, this is row 1, row 2, and row 3. I can like change the order of the rows, right? Put this row up here. Doesn't matter. We are going to start eliminating everything that's over here in the X position until we get these to be zeros. which is no different than before. Okay, so 1, -2, -4 is 9. That's no different. Okay, but what I'm going to do to make this next row is I'm going to take row 1 and I'm going to subtract, or sorry, I'm going to take row 2 and I'm going to subtract 3 times row 1. Same as I did before.
I already don't like this. This looks terrible.
No, it's not that bad. It's just the same thing.
Oh, I get what's going on.
Yeah, okay. Here we go. I'm going to take row 2 and I'm going to subtract 3 times row 1. So 3 minus 3 times 1 is 0. 4 minus 3 times -2 is
4 plus 6.
10. Yes. 3 minus 3 times -4,
15.
3 minus 3 times 15. Yeah, you're right. Okay, this is where we made our mistake last time, so let's not do this. Okay. So this is -8 minus 3 times 9. Yeah, minus 3 times 9.
-35.
-35, there we go. And Morgan, did you just read that off from the equations from before?
No, I had to double check. I was a little bit confused for a second.
Okay, all right. Let's do the same thing. I'm going to eliminate the 2 from this row, from row 3. Okay, so I'm going to take row 3. How am I going to eliminate the 2 from row 3?
2 times.
Times R1.
I'm going to go 2 times minus 2 times R1. Yes, there we go. Okay, 2 minus 2 times 1, 0. That's exactly what I want to happen. Okay. And now I've got, 1, 3. 1 minus 2 times -2.
-3. What?
1 minus 2 times -2.
-1.
1 minus 1 plus 4 basically is 5. I'm going to do 6 minus 2 times -4. 14.
That was a guess.
Was it? Okay. I think that's right. 6 minus. Yeah.
6 plus 8.
6 plus 8. Yeah, that's right. Okay. So 7 minus 18.
27. So.
-11.
Oh, 18, sorry, yeah, it's 2 times.
-11.
Uh-oh, where's the negative 11?
So 7 minus
Oh,
18. -11. Yep. Okay, good. I've gotten rid of my X's. Now I need to get rid of this so that I can read my Z off. Hopefully we haven't made a mistake. Maybe we did. Let's see what happens. Okay, so 1, -2, -4 equals 9, 0, 10, 15, -35. Okay, there's my row 2. I am going to make this row, I'm going to do 2 times row 3 from up here. I'm going to take 2 times this, and I'm going to subtract row 2. Okay, 2 times 0 minus 0 is, you said 0, you are absolutely right. 2 times 10 minus 10, 0. 2 times 28, sorry, 2 times 14.
Wait, 2 times 5 is 10, not 0, isn't it?
Yes, but 2 times 5 is 10, and then I subtract.
Whoa.
There we go. Okay. 28 minus 15. I'm hoping this is 13. And this is the one we're worried about right here. Because if this doesn't turn out to a -1, we are in trouble. Oh, it's going to work. I know it is. Okay, negative 11 minus negative 35. Sorry, negative 22 minus negative 35 is 13. Did we get it right?
No, because one should be negative.
One should be negative. 2 times r 3, negative 22. Oh, one of these should be negative.
The one on the left.
This one right here. Okay. There we go. All right. So already I'm ready to say z is equal to negative 1. So this is matrix reduction. Same idea as before. Okay. Just leave off all the variables. Do what we want. Just a different way of representing it. Potentially a little neater. You eliminate the left-hand variables first. That's just the convention that we follow when we're doing matrix reduction. Okay? This intersects at a point. Good enough? Morgan, does it make sense even though there's lots of mistakes?
Yep.
Okay. We are only looking at one other example, and I'll put the system of equations up. You guys tell me what you think it looks like when we get it into 3 dimensions. Okay?
I'm gonna guess they're gonna intersect on a line, but that's just because.
And that's because that's what came next.
Yeah, that's probably gonna progress.
Yeah. Okay. So actually, when you look at it, I'm pretty sure you're going to figure it out. So here's my equation: 3x minus 12y minus 6z. Negative 4x plus y plus 3z. Negative x plus 4y plus 2z. Okay. Let's put it into a matrix. Oh, let's decide what we want to do. Do we want to do this using the matrix? So 3x minus 12y. So 3, negative 12, negative 6, negative 9, negative 4, 1, 3, 1, negative 1, 4, 2, 2. There it is. Matrix form right there. All right. Hey, Morgan, what do you notice about these planes, or at least the normal planes?
Can you move it slightly to the left so I can see them?
You are so high maintenance.
Mm-hmm.
I can't believe we can't see it.
Oh, well, the first 2 are parallel, and the other one is not,
First 2 are parallel.
aren't they?
These 2? No,
Oh,
actually.
never mind, I'm lying to you. I am. I thought that was negative. I don't even know what I thought. Okay.
If you look at this one and this one, okay? If you look at the normals, negative 1, 4, 2.
Hey, those ones are scalar multiples.
Yeah, these normals are scalar multiples, okay? So this plane is probably parallel or possibly coincident. This plane.
But it's not coincident because one equals to the one equals negative.
Yeah, if you actually do this, yeah, you'll actually see they are not coincident.
If is it equal, one equals 2, one equals negative 9, if those were scalar multiples, then it would be coincident.
Exactly, yeah, so if this was a scalar multiple of, if this was the same scalar multiple, then those lines would be coincident.
Yeah.
Okay, yeah. So basically, this one, just by inspection, we know it is not going to be, we know it's not going to be parallel with these, okay? It's not, the normal's not a scalar multiple. So to give a little drawing, okay, here's one plane, like that. Here's the other plane. They are parallel with each other. And then there is a third plane here, okay, and it's intersecting these 2 planes. Nice try. Thank you very much. It's almost like you could reach out and touch it. Okay? There is no solution to this system. there's no solution to the system because these planes are not occupying the same space at the same time, okay? Basically, if I did these two planes, I would get a point of intersection. If I did these two planes, I would get a line of intersection. I would get a line of intersection here. But if I do these two planes, I get something crazy. Okay? So let's try. So let's try taking row 3. So 3 times row 3. Plus row 1. That's what we're going to do. We're actually going to see if we can, we're going to flirt with danger here. And yes, we're going to look at what it looks like. Okay, so 3, -12, -6, -9. We're not going to look at this one. But if I do these two together, I'm going to get a line. All right, 3 times row 3, so -3 plus 3 is 0. 4 times 3 is 12, plus -12 is 0. And 6 plus -6 is 0. Oh my goodness, with this. And 2 times 3 is 6, plus -9 is.
Aren't they already parallel?
What's that, Morgan?
They're already parallel, right? When you got the 3 zeros.
We already know that, but I'm just showing you what the solution is going to look like. Okay. So this is like saying 0z is equal to -3. So there is no intersection. These are not intersecting in a line like yesterday. They're not intersecting at 3 points. We have 2 parallel lines. This is just never true. 0 times something can't equal to 3. So we know we've got a parallel line. Tomorrow we'll look at a thing called the dot cross product that you've seen in the preamble.
And is that gonna almost find 2 lines?
No, the dot cross product is just a test you can do to see what your planes are doing.
So would we be given a question where we would have to find the 2 lines of?
Exactly. So I might ask you, find the equation of the line of intersection, okay? Or you might be asked to find the 2 lines.
Yeah.
Okay. So what would that look like?
Gonna have an intersection with, per se, 1 and 2, and 1 and 3.
Yeah, so I can look for the intersection of row 1 and row 2.
Yeah.
And I can look for the intersection of row 2 and row 3. Just doesn't work if I do row 1 and row 3. Okay. And do we want to do this? I don't know. Let's see what it looks like, just for a second. Okay. So basically we have to take, this is going to be ugly. It's going to be ugly, but it's not going to be that ugly. Okay. So I'm going to leave row 1 alone. 3, -12, -6, -9. Okay. I need to make this a 0. So this is how I do it. I'm going to take 3 times row 2. And I'm going to subtract, I'm going to add 4 times row 1. Because I know that's going to make this first one 0. Okay. 3 times row 2, so -12 plus 12 is 0. Got it. 3 plus -48. 3 plus -48 is -45. That's a big number. Okay. 9 minus 24. 9 minus 24.
15.
9 minus 24 is -15.
That's hard, I'd work.
That is, okay, so 3 minus 36 is
Oh, 33, -33.
-33, yeah. Okay. So wow, this is just horribly ugly, so we're not even gonna pursue this. It is just ugly. This is -45y minus 15x equals -33. Or 45 y, oops, z, sorry, that should have been z. 1 plus 15z, 33. Okay. There's the equation of a line between those two, planes, right there. Okay, that's as simple as I can make it. That's the equation.
I could do that the other way though, right?
Yeah, you can do it any way that you like. If I follow what you mean, Morgan, like you can pick whatever line you want. Or do you mean like do it with the equations?
Yeah, do it with Dick.
Yeah, that's right. You can do it with the equations. Yep. I might specify though you've got to use a matrix because you're supposed to be able to do it. You can do it, Morgan. All right. I've got to go do some WMIS labeling.
Yep, sounds good.
Okay. Do the homework. Wednesday. Last lesson is Monday.
Yeah, thank God.
You're welcome.
Yeah, thank you. I'm reaching the end of my brain capacity.
Well, yeah, so it's going to be good because this is going to give you, another period, right? Every day.
Yeah.
All right. Good. Thanks, Morgan.
Yep, thanks. Bye.
Bye, Manuel.
Bye.